So I know you guys are facing a lot of problems in this corona era, but that doesn't stop us from studying. So let's study the unit number 2 of Special Technology 4 U.3. Okay. Explain testing and analysis of raw rubber. Raw rubber materials checking include essential chemical, analytical, and physical mechanic measuring, the results of which are mostly physical parameters. On the base of these physical parameters, it is possible to assume the raw material purity. The parameters are as such: determination of the melting point, moisture, volume, dry mass volume, percentage of ash or volatile substances. Okay, so these all parameters you should define while testing the raw rubber. Determination of liquid sample viscosity, specification of effective substance volume, specification of heavy metals, refractive index, acid value, and others. From the methods used for entry raw material quality control, it is required to be quick, exact, and their result should be in correlation with the material purity. So let us see one by one melting point. What is melting point? It is the temperature at which the sample changes or consistency takes place. Sample change of consistency. It is from the solid state into a liquid state. तो जब एक मटेरियल सॉलिड से लिक्विड में कन्वर्ट हो जाता है उसे मेल्टिंग पॉइंट कहता है. The liquid phase and the solid phase are in dynamic balance. It is one of the compound purity criteria. The temperature is dropping down at the moment when a small dirt content is present. With impure substances, the transmission is not so sharp. Therefore, there is a temperature melting point interval expressed along with it. Determination of mixture melting point is based on the assumption that the mixture of two different non-isomorphic substances is melting at considerably low temperature than respective pure compound. So, melting point is sharp for pure substances, but it is not sharp for impure substances. Okay, so non-isomorphic substances are non-crystalline, not having the same crystalline structure. Therefore, if two substances have the same melting point and they are same, then their melting point will also be same. If they are different and their melting point will be lower, melting point is determined by accelerators. Melting point is determined by accelerator, anti-degradants, and others. So, determination of a mixture of melting point is based on the assumption that the mixture of two different isomorphic means having same crystalline structure. So non-isomorphic means not having same crystalline structure. Substances melting point is considerably lower. So if you take a mixture of two things, then melting point will be lower as compared to if they are taken individually. Therefore, if two substances have same melting point and they are same, then their melting point will also be same. Means the mixture. If they are different, then their melting point will be lower. Okay, got it? Melting point is determined at accelerators, anti-degradants, and others. Dropping point. Now, it is the temperature at which the substance, while being heated at certain rate, will be softened up to such a point that originated drop will drop down by its weight. So what happens whenever you are melting a plastic, okay, or even a candle, for example, if you start burning the candle and if you hold it horizontally, then there will a bubble appear and that bubble will fall down by its own weight. So that is the dropping point. I'm just telling you for example, it is similar to determine dropping point by a circle of ball, where generated drop will drop down by gravity force effect of the steel ball. Dropping point is determined at resins, California, and asphalt. So colophony is a rosin, also called colophony. It is a solid form of resin obtained from pines. Okay, and asphalt is bitumen. Okay, it's a sticky black, highly viscous liquid, semi-solid form of petroleum, bitumen. Now, volatile substances. They are compounds that are being released from a sample during temperature increasing. The temperature of 105 degrees Celsius is mostly used at determination of compounds. In most cases, it is water or volatile organic compound expressed to the original sample backfill in percentage. It is determined at carbon black, silica, organic chemicals, accelerators, and others. So all the substances, volatile substances are the ones when you increase the temperature, they get into the atmosphere they are liberated into the atmosphere in form of gases. So they are volatile. In most cases, it is water. Water gets evaporated first. Now, dry mass. It is the rest of the sample after defining the volatile substances. So you once get the amount of volatile substances, you simply subtracted it from the weight of the sample, you get dry mass. Or if appropriate, humidity. It is stated that percentage of the original sample backfill. It is determined at liquid samples of cements and separating agents. Okay, it is stated in percentage of the original sample backfill. Means how much percentage of dry mass was there in the original sample. Now, ash. It is composed of organic at a certain temperature, non-volatile, and further indecomposable compounds. Okay, which are parts of the sample. Due to decomposition of some inorganic compounds, example carbonates, sulfides, the ash volume does not have to define inorganic parts share in a very exact way. It is stated in percentage to the original sample backfill, and it is necessary to indicate. An ash test involves taking known amount of sample, placing weight sample into dry pre-weighed porcelain crucible. So first you weight the porcelain crucible, then you tear it to zero, and then you place the sample on that crucible, burning away the polymer in air atmosphere at temperature above 50. Then you increase the temperature to 500 degrees Celsius and weighing the crucible after it has been cooled at to room temperature in the dedicator. Ash residue remaining in crucible is considered filler unless residue is less than 1% of the typically result of additive that did not burn off. So the ash is always remain after burning. So that is the ash. So ash residue remaining in the crucible is considered filler unless residue is less than 1%, are typically result of additive that did not burn off. So there are sometimes the additives don't burn out. Polymer contains additives, and polymer gets burned entirely at 500 degrees Celsius, but still the additives added in that polymer are remaining. So that's why they can be used as a filler. So now data. Ash test results is expressed as percentage ash. Magnified optical examination of ash residue is performed to determine if ash is glass, minerals, or combination of both. Total ash content equals weight of ash divided by weight of organic sample multiplied by 100. So percentage ash content is weight of substance after heating upon initial weight into 100. Specimen size 6 grams of samples typically used, which represents 3 crucible each containing 2 grams of sample. Okay, 6 divided by 2, 3 samples, we get it. Smaller sample weight can be tested, but accuracy diminishes. Therefore 2 grams you have to take with smaller sample size. Typically average of 3 crucible is reported. You cannot just take one crucible and determine the ash content. You have to take at least 3 crucibles so that you get the average, you get the real reading. Now acid number. It is the amount of alkali hydroxide necessary to neutralize in a sample of present compound. Okay, it is defined in mgQH per gram of the sample. It is determined by volumetric method at samples which contain free acids such as resin and some softeners. Acid value or neutralization or acid number or acidity is mass of QH in milligrams that is required to neutralize 1 gram of chemical substance. Acid number is measure of amounts of C11OH group in a chemical compound such as fatty acids or in mixture of compound. In typical procedure, known amount of sample dissolved in organic solvents is titrated with solution of QH with phenolphthalein as a color indicator. Formula for calculating acid value is 56.1 into normality of QOH into volume of QOH upon weight of the sample. Okay, so atomic weight of QOH is 56.1. Okay, now active substances determination. Now ordinary industrial chemicals are mostly not used as pure ones, but they form a mixture with various additives which make processing easier. In some cases, they may improve hygiene of work. Due to appropriate quantization, it is necessary to know the content of substance active of the industrial chemical. For determination of substance active, different analyzing methods are used, beginning with volumetric analysis, redox, neutralization, coagulating, or complex forming titrations, up to modern instrument method like GC and HPLC. So GC is gas chromatography, HPLC is nothing but high performance liquid chromatography. Okay, so and the meaning of quantization is nothing but is a process of mapping continuous infinite values of a smaller set of discrete finite values. Okay, quantization is the process of mapping continuous infinite values to a smaller set of discrete finite values. So, carbon black testing. It covers essential determinations accessible in each laboratory. They are such as determination of pH of carbon black, determination of volatile substances, ash content, sieve residue analysis, oil absorption number, iodine absorption number, tint strength, transmittance of toluene extract, powder density, individual palette hardness, dust content. Okay. So carbon black testing covers these essential determinations. Sieve is nothing but a screen, having a net for separating solids from liquid. Now, interaction degree of rubber with carbon black depends on three major factors: contact surface size of carbon black and rubber, so called extensive factor. Second, structure of carbon black, so called geometric factor. Surface activity, so called intensive factor. Carbon black testing also covers the following method: determination of iodine absorption number, determination of cetyl trimethyl ammonium bromide absorption, determination of specific measuring surface, determination of oil absorption number, volatile substance content, pH carbon blacks. Okay, so carbon black is a rubber enforcing additive used in a multitude of rubber products. Large amounts of carbon blacks are used for tires. So now you have to do all these tests. Carbon black testing also covers the following methods. So you have to know everything: determination of iodine absorption number. Iodine number indicates milligrams number of iodine that is being absorbed on the surface of 1 gram of carbon black. By number, iodine number is equal at usual retort carbon black as their specific surface determined by nitrogenous absorption. Then absorption of large molecules which cannot enter microscopes. It gives information about effective outer surface that is accessible for rubber molecules. It is based on nitrogen absorption at low temperature when monomolecular layer is being formed. Nitrogen has small molecules, it is chemically inert, and its absorption does not depend on chemical character of carbon particulate surface. Now, dibutyl phthalate adsorption is added to carbon black and torsion moment is being read. At dibutyl phthalate saturation by carbon black, the torsion moment is suddenly increased or resistance against snedding. Volatile substance content. Carbon black sample is being heated up at certain temperature and the content is determined from difference between the weight before and after heating. Like I already explained this one. pH carbon black. Carbon black has dispersed in distilled water, boiling slurry and sonic slurry, and the pH of such dispersion in water is determined. Now this is an interesting one. Plasticity retention index. This mechanical testing substitutes more time demanding and more expensive analyzing determination of heavy metals in rubber. It is based on the matter of fact that some heavy metals present in the rubber sample at increased temperature cause destruction of rubber polymer string. Polymer molecular weight is dropping down as well as its physical mechanical properties, viscosity, plasticity also drop down. Raw rubber sample is recalendered and divided into two parts. One of them is thermally loaded with 140 degrees for 30 minutes. Plasticity value, plasticity deformation measure, will be determined for both samples. Plasticity retention index PRI is figured out as follows. PRI equals to P30 slash upon P0 into 100, where P30 is plasticity after thermal loading of 30 minutes and P0 is plasticity of the sample that was not thermally loaded. If a sample does not contain increased amount of heavy metal, PRI value is low because these heavy metals only contribute to the deterioration of the plastic. So if the sample does not contain increased amount of heavy metal, then PRI value will be low. Means plasticity deformation measure will be low. Rubber product testing physical property. Evaluation of the physical properties of rubber, plastic and elastomeric materials can be used to predict the durability and performance for use in a multitude of final product application. So all these methods are there: abrasion testing, electrical testing, puncture resistance. So you just need to know this table. That's it. Okay. Now